Have you ever looked out at our modern world and just wondered how life hangs on? I mean, you see these little patches of forest or wetlands kind of squeeze between roads in cities. Some of them seem to be doing great, while others just fade away. Well, today we're going to dive into the really powerful ideas that explain why this happens. It's a fascinating story about how we went from seeing nature as a bunch of lonely islands to seeing it as a living, breathing network.
Just look at this. It's a scene we all recognize, right? This patchwork of natural spaces and human development. But where we might just see a pretty landscape, ecologists and landscape architects, they see a huge puzzle. A really fundamental question that's been driving their work for decades.
And here's the question. Why is it that some of these fragments of habitat can support life, while others, sometimes right next to them, just slowly lose their species and, well, collapse? To find the answer, we have to go back in time. Back to the 1960s, to a surprisingly simple and really elegant idea that was inspired by, of all things, actual islands.
So the first real crack in an answer was something called the Theory of Island Biogeography. It turns out, before we could understand a forest cut up by roads, we had to first look at an island surrounded by an ocean.
The real genius of this theory is just how simple it is. Two ecologists, Robert MacArthur and E.O. Wilson, they suggested that you could pretty much predict how much life you'd find on an island just by knowing two things: how big the island is and how far away it is from the mainland. That's it.
And the way it works is super straightforward. First, you've got colonization. It just makes sense, right? It's way easier for new plants and animals to get to a big island that's close by. Then you've got extinction. On a small, isolated island, populations are smaller, resources are tight, so they're much more likely to die out. The number of species you find on that island is just the balance point, the equilibrium between these two things pushing and pulling. And for a long time, this was pretty much the gospel.
But what happens when you take that nice, neat island rule and try to apply it to a messy, real-world landscape on land? Well, that's when things start to get complicated. A patch of forest, it turns out, is not quite the same as an island out in the middle of the ocean.
And here you can see the problem. The island theory basically assumes that the space in between the habitats, what ecologists call the matrix, is like a totally hostile ocean. But a cornfield isn't a deadly ocean to every creature, and it's certainly different from a suburban lawn. The theory also assumes things eventually settle into a nice, stable balance. But real landscapes, they're always changing. And maybe most importantly, it assumes all patches of habitat are basically the same. And as we're about to see, that is absolutely not true. So moving past this idea wasn't just a small tweak. It was a complete overhaul in how we think about life in fragmented places. As the source material points out here, a lot of scientists called this a full-on paradigm shift.
So if the island model wasn't quite right, what took its place? A new idea that was built for complexity and change: the metapopulation.
This idea, first really developed by Richard Levins, forces us to see the bigger picture. It's not just about one population on one little patch. No, it's about a population of populations, a whole network of smaller groups that are all connected because individuals can move between them. So in this new model, a local group winking out isn't the end of the story because that empty patch can get recolonized by its neighbors. It's all about the network.
Okay, but the theory gets even cooler and more powerful because it turns out that within this big network, not all the patches are doing the same job. And this next idea is absolutely critical for understanding how these systems actually stay alive.
So here's the key distinction. You've got source patches and sink patches. Think of sources as the engines of the whole network. They're awesome, high-quality spots where there are lots of babies, not a lot of deaths, and they actually produce a surplus of individuals. Sinks, on the other hand, are a bit of a trap. They might look perfectly fine, but they're lower quality habitats where more individuals die than are born. If a sink were left all alone, its population would just disappear. And here is where it all clicks together. See those extra individuals from the source patches, the dark green ones? They don't just stay put, they spread out across the landscape, and they end up in those sink patches, the lighter green ones. They are constantly bailing out those struggling populations, saving them from winking out. It's this hidden flow of life. A sink can only survive because it's getting a constant subsidy from a source nearby. And this creates a really dangerous illusion for anyone trying to do conservation or planning. I mean, you could look at a bunch of animals in a sink habitat and think, wow, this spot is great, let's protect it. But if you don't realize that its lifeline is a source habitat maybe a few miles away, and you let that source get turned into a shopping mall, well, that sink population is toast. You've basically just set a timer on its extinction.
So, what's the big takeaway here? Why does all this theory matter?
Well, because these ideas aren't just for textbooks, they are the bedrock principles that landscape architects and conservation planners use every day to design places that actually work for nature.
You see, the biggest enemy for planners is fragmentation. Our roads, our buildings, our farms, they slice and dice the landscape, cutting all those crucial connections. So the whole goal of ecological design is to fight that, to stitch the landscape back together and let that flow of life happen again.
And metapopulation theory tells us exactly what we need to build. It shows us which patterns are non-negotiable. We need big patches, those are our likely sources, and we absolutely need corridors connecting them so individuals can move back and forth. This isn't just a nice to have, it's the basic plumbing of a healthy ecosystem. And these corridors don't have to be massive national parks. They can be working parts of our landscape. That strip of trees and shrubs along a creek, that's a corridor. A line of trees planted to block the wind on a farm, that's a corridor. Even the cleared land under a power line can act as a highway for certain species, connecting populations that would otherwise be totally cut off.
Now, I want you to remember this number, 30 to 50%. Research shows that once the total amount of habitat in the landscape drops below this critical threshold, the rules of the game change completely. All of a sudden, the arrangement of the patches that are left becomes more important than the total amount. Below this point, having good connections isn't just important, it's everything.
So you can really see how our thinking has grown up. We've moved way beyond just thinking about how big a patch is or how far away it is. To build resilient landscapes, you have to think like a landscape ecologist. You have to figure out which patches are your crucial sources and protect them. You have to think about what the land in between is like. And most of all, you have to design for connectivity.
Which really brings us to this final, massive question. As we continue to shape our world, every single design choice we make is an answer to this. Are we just building a future full of fragmented, fragile islands that are doomed to fail? Or are we going to be smart enough and caring enough to actually design the resilient, interconnected networks that life depends on?